Here we introduce our work Free3D, consistent no view size without 3D repetition. This work is done by Chen Xiazhen and Andrew Fedeli in the VGG at the University of Oxford. In this work, we propose a simple approach for open set consistent no view size. Give a single image of Free3D directly output consistent no views without relying on an explicit 3D repetition. Here are some examples. The model is trained only on object dataset, and it achieves realistic results on real scanned objects, such as the objects from Omnia Object 3D and Google scanned objects with various categories. We first introduce the motivation for open set 3D reconstruction from single view images. Reconstructing 3D reconstruction from an image from a single 2D image is a fundamental challenge in computer vision and is highly opposed. To achieve this goal, we need to address the following challenges. First, the model needs to learn pre-knowledge from large-scale dataset. Fortunately, currently we have a lot of pre-trained large vision models such as CLIP, dialogue, stable diffusion. We can use the pre-knowledge from those large pre-trained vision model. Second, the model needs to achieve precise pose perception from arbitrary camera viewpoints. Finally, when several views of the same object are rendered, they must be multi-view consistent. To achieve this goal, Z123 fine-tunes a large-scale pre-trained 2D generator for 3D no view size by conditioning the camera viewpoints such as elevation, azimuth, and distance as global language tokens. While it has good generalizability, Z123 fails to achieve high pose accuracy, and these reconstructions are not very consistent across different views. To mitigate this issue, we propose multi-view diffusion pipeline, considering multi-view jointly instead of process them independently. More interesting, we introduce the ray conditioner normalization layer, which injects per pixel camera ray to modulate the latent feature. This is quite different to existing methods, which only consider the camera viewpoints as global language token, which may be hard for the network to interpret and understand and utilize. Here we expand with a number of different architectures. The first one is concatenation, which combines the noise target, source embedding, and camera ring embedding as one input. Then we also consider to apply this ring embedding into every layer of the UNet. Finally, we present the ray conditional normalization layer, which uses the ray embedding to modulate the latent feature with this function, where the gamma and the beta are the render scale and shape from reconditioning. Interesting, where reconditioned normalization works best, we show that all such architectures lead to strong improvements. This suggests that the local ray embedding is a key part of the observer's improvement. Here are examples on different datasets. Free3D achieves better results even under challenging viewpoints with very different categories. To further ensure the consistency, we introduce a pseudo 3D coarse attention layer to merge information between different frames. This is inspired by the video diffusion model. Similar to our ray conditional normalization, this pseudo 3D coarse attention layer is also applied in every intermediate lane. In order to reduce the variance between different views, we also propose to start sampling each view from the simple noise vector. Here we first show the qualitative comparison of our model to the SOTA Z123L. As we can see, our model can mitigate the flattering and incorrect pose and output consistent video rendering without the need of any conditional 3D repetition and networks. We also show some rendered video on the large object dataset. As we can see, those 360-degree video is very consistent on different categories, even without any 3D repetition. We also directly evaluate our model on new datasets, such as the Omnia Object 3D, which scans many objects from our daily life. As we can see, our Free3D outputs consistent video for various categories. Finally, we also show some examples on the Google scanned object, like with different categories. They also show some smooth results. Thanks for your attention. More results and conclusion can be found on our website, and the code are released in this link.